Okay, this is our third review notes for our final exam. We are looking at rational expressions, simplifying them, adding, subtracting, multiplying, dividing, that type of thing. To keep in mind, when you are simplifying a rational expression, you need to make sure and factor first. Then you can reduce out common factors. So our first example here, 2x minus 6, we could factor a 2 out of that. We would have an x minus 3 factor remaining. And on the bottom, we have x minus 3. Since we have matching factors, we can take the x minus 3's out, and our final answer would just be the 2. Okay? Our second example, there's nothing we can do on the top, so we're going to leave that as x plus 3. But we can factor that trinomial that's on the bottom. Our x squared, we would split into an x times an x. And then we need numbers that multiply to be negative 21. So let's think about that. To get a negative 21, you could use 1 times negative 21, or its opposite, negative 1 times positive 21. We could use negative 3 and 7, or its opposite, 3 and negative 7. Since we're trying to get a negative 4 here, we're going to need to use that option. So we need a positive 3 and a negative 7. And again, we have some common factors, so we could reduce out the x plus 3's. And since the x minus 7 is on the bottom, we're going to put a 1 on top to show that that x minus 7 is still on the bottom. All right, the third example, x squared minus 49. This is what we call a difference of squares. And we learned how to factor that into x plus 7 and x minus 7. On the bottom, it's not our normal trinomial, but we do have a common factor of 10 and a common factor of x. So we're going to factor out that common piece. 10x squared divided by 10x would be 1x. And negative 70x, if we divide out the 10x, would be negative 7. And again, looking for common factors, we can get rid of the x minus 7s. So our final answer would be x plus 7 divided by 10x. All right, so that's when you just have a single fraction that you're just simplifying. The next part is we are multiplying. So our steps, you should factor, you should reduce, and then multiply across whatever's left over. All right. Now the first example has no plus minus signs in between any terms. You simply have a monomial expression in each of those pieces. You have a 2, a 5a, an a squared, another 2. They don't need to be factored at all. So we're going to go right to the reducing part. Do we have any factors that match? You need 1 on the top with 1 on the bottom. And since we don't have any common factors that match, we can't reduce this one. All we can do is multiply straight across, the 2 times 2, and the 5a times a squared. Remember, there's a 1 here for a power, so we really have a 5 times a to the third. All right, our next one. We do have some plus minus signs in here, all right? So we do have to do some factoring. Y squared minus 36 is another one of those difference of squares. So we can factor that into y plus 6 and y minus 6. We have just a monomial of 2y on the bottom, so we can leave that. We're multiplying it to a monomial 6y over the quantity y plus 6. Looking for common things. We have a factor of y plus 6, top and bottom. We can cancel those out. We also can reduce the 2y and the 6y. The 2 and 6 turn into 1 and 3. And since there's a single y on each of those, we can get rid of those pieces. So what we have left on top is the 3 and the quantity y minus 6. And we have nothing left on the bottom. Question. We are dividing. There's one extra step we have to do. We have to flip the second fraction first. Then we can treat it as if it was a multiplication problem. It's called multiplying by the reciprocal. So let's go ahead and factor this as we go. We have a regular trinomial here. We need numbers that multiply to be 14 and add up to 9. We could use 7 and 2. On the bottom, we have another difference of squares again. It factors into x plus 2 and x minus 2. And since it's division here, we are going to have to flip those two. So we're going to change it to multiplication. The x minus 7 is going to move up to the top, and the x plus 7 is going to move to the bottom. And then once again, we look for things that we can reduce. I see an x plus 2, one on top, one on the bottom. I also see an x plus 7, one on top, one on the bottom. What I have left is x minus 7 over an x minus 2. All right. The last division problem here is a little different than most of the ones that we worked on this semester. We are taking this 9m to the 5th minus 6m cubed. We are dividing by a 3m squared. There's a couple ways you can do this. Since you're dividing by just a plain monomial, you can divide each term on the top by that. So we could split this up and say that's 9m to the 5th divided by 3m squared minus 6m to the 3rd, and it's being divided by 3m squared. All right, and then it's just a basic simplifying process. 9 divided by 3, we could reduce that. We end up with 1 and 3. We have 5 m's on the top and 2 m's on the bottom. Since there's more on top, we're going to have our leftovers on the top, and we simply subtract the powers. So we would have 3 extra m's on top. Our second fraction, we have a 6 and a 3. We can reduce that to 1 and 2. We have 3 m's on top and only 2 on the bottom, so we can get rid of 2 of them from each position, and we're going to have 1 left on the top. So we end up with a 2 and an m as our second term. Okay? That's one way of doing that problem. You could also tackle that one just using our regular factoring idea. So we could take 9m to the 5th minus 6m cubed. We're dividing by 3m squared. And we could think of factoring. So if we factor from the top, we have a 9 and a 6. They both have a 3 in common. They both have at least 3 m's that are common. And what we would have left over is a 3m squared from the 9m to the 5th. And if we factor out a 3m cubed from 6m cubed, sorry, we're factoring out, yeah. Take out a 3m cubed from 6m cubed, we would have negative 2 left. All right. We are then dividing by 3m squared. Okay? So the 3's would drop out. We could take 2 m's from both, which would leave us only 1 left here. So we end up with m times 3m squared minus 2. And if you wanted to distribute that, you would have 3m cubed minus 2m. Ends up being the same answer that we got here. So either way is fine. Remember, this is a multiple choice final, so you just have to remember, be able to pick out your correct solution. All right. The last part that we need to review, we are adding and subtracting. In this case, we must have a common denominator. All right, and for this particular problem, we already do. Both denominators have an x squared minus 4. So as long as they match, we can keep that as our denominator. And then we have to simply do whatever it says to do on the top. In this case, it's telling us to take x minus a 2. Now, if you recognize x squared minus 4 in the denominator as a difference of squares, you should be able to factor that into x plus 2x minus 2. And then we can do some reducing. So we can cancel out the x minus 2's and end up with 1 over x plus 2 as our final answer. All right. Then we tackled some proportions. When you are solving a proportion, you have to cross multiply. All right, this would have been in Unit 4. Cross multiplying. We are going to take 4 times x minus 3, and it has to balance with what we get when we cross the other direction, 2 times x plus 2. Next step is to distribute. So 4x minus 12, we're just multiplying that in. On this side, we multiply in a 2, we get 2x. Multiply it to the other 2, we get a 4. And now we have a linear equation. We have variables on both sides, so we're going to get those variables all together. So I'm going to subtract 2x to the other side. That leaves me 2x minus 12 equals a 4. Since I've moved all the variables to the left side, I'm going to move this constant over to the right. So I'm going to add the 12 over. That gives me 2x equals 16, and my last step would be to divide over 2. So x equals 8. All right, again, make sure you have these notes out so you can use them as you're working through your worksheet.